Today we're going to start factoring in Chapter 10. We're going to start by factoring the trinomial ax squared plus bx plus c, but we're going to concentrate on just when a is equal to 1. For instance, we might be asked to factor x squared plus 8x plus 15. Notice that the coefficient of x squared is 1. Here's what we're doing. We're looking for factors of 15c that add up to 8, which is b. And this is always going to be the case when we're factoring ax squared plus bx plus c when a is 1. We're going to look for factors of c that add up to b. So there's a limited number of factors of 15, but you can go through them in your head pretty quick, like 1 and 15, 3 and 5, and there we go. 5 times 3 is 15, and 5 plus 3 is 8. It really doesn't matter which order you have them in. Now we're ready to factor this trinomial. X plus 5 times x plus 3 is the factorization of the original trinomial. And we can check this answer too by multiplying the polynomials. X times x is x squared, x times 3 is 3x, 5 times x is 5x, and 5 times 3 is 15. When you combine like terms, we're left with the original trinomial. So let's try this one. Again, we're looking for factors of 20 that add up to -9. This one might take a little bit more thought, 1 and 20, 2 and 10, 4 and 5. But actually, -5 and -4. A negative times a negative is a positive, and a negative plus this negative is going to give us -9. So it makes it a little bit trickier when this is negative. But we know the factors of 20 both have to be negative, and this, because that's the only way we can get a negative sum. So that means our factorization of the original trinomial would be x minus 5 times x minus 4. Check that answer again. X times x is x squared, x times -4 is -4x, -5 times x is -5x, and -5 times -4 is 20. Combine like terms, we see we get the original trinomial. That's what factoring is. It's taking the original trinomial and turning it into two values, in this case binomials, that you can multiply together and get the original trinomial. A couple more of these here. Okay, now we're looking for factors of -9 that add up to -8. Pause for a second and remind you that this process only works when the coefficient of x squared is 1. Okay, we'll deal with other ones in tomorrow's lesson when a is not 1. So factors of -9 that add up to -8. The only way we can get -9 is for one of these values to be positive and one of them to be negative. The smaller number, the easier it is to recognize, but by going through the factors of -9, or maybe just the factors of 9 and looking for, numbers that when you subtract them you get -8, you're going to quickly realize that -9 and 1. -9 times 1 is -9, -9 plus 1 is -8. We always need these two sets of numbers to be the same. So now we can write our factorization. It's x minus 9 and x plus 1. That's all we're looking for, and we can go ahead and check our answer as well by multiplying the two binomials, which we learned in an earlier lesson. X minus 9x is -8x when you combine like terms. Alright, so now we're looking for factors of -18 that add up to 3. Okay. Again, we've got a negative c value, so one of these values has to be negative. We have a positive b value, so the bigger one should be positive. How about 6 and -3? Okay, 6 times -3 does equal -18. and 6 plus negative 3 does equal positive 3. If you had the negative sign in the wrong spot, negative 6 times positive 3 would equal negative 18, but negative 6 plus 3 would equal negative 3, so that wouldn't work. So our factorization would be x plus 6 times x minus 3. And again, we can check our answer. This is all multiplying binomials, which we learned in an earlier lesson. It should also be noted that these two binomials can be reversed. It doesn't matter if you have x minus 3 and x plus 6. All right, one more thing. Not all trinomials can be factored. If you're looking for factors of negative 7 that add up to 6 and you're having a hard time, maybe stop and evaluate the discriminant, b squared minus 4ac, of the trinomial. So in this case, 6 squared minus 4 times 1 times negative 7, which comes out to 36 plus 28, which is 64. Now, 64 is a perfect square, and because 64 is a perfect square, that lets me know that x squared plus 6x minus 7 can indeed be factored. Again, if the value of the discriminant is a perfect square, then the trinomial can be factored. Spelled discriminant wrong there, didn't I? Okay, now let's look at the second one here. Maybe you're having trouble looking for factors of negative 5 that add up to 6. Again, we can look at the discriminant, 6 squared minus 4 times 1 times negative 5. See, 56 is not a perfect square, and that tells us that this trinomial cannot be factored. If the discriminant is a perfect square, the trinomial can be factored. If it's not a perfect square, it cannot be factored.